Hello everyone, welcome back to the channel. So let's get started. Everywhere you look, you'll find lines meeting at angles, whether it's roads intersection or railway crossing. You can see the pictures on the screen. Even the blades of a pair of scissors. There you can see the angle formation. You can see the aerial view of road junction here, which is a perfect example how two parts meet and create an angle. Similarly, railway crossing here, which is a perfect example how angle appear in infrastructure. In the first picture, which is an aerial view of crossing roads, perfect to illustrate how two lines meet at various angles in day-to-day life. This angle is not just important in geometry, it's used in road design, architecture, or even in computer graphics. In mathematics, when we have two lines on a graph, we can find angle using their slopes, no physical measurement needed. Today, I'll show you how exactly we're gonna find the angle between any two lines, just like whether they meet like roads at a junction or like the arms of a clock. We will start with the concept of slope, then use it to calculate the angle. So by the end of this video, you will be able to find the angle between any two lines. So let's get started. So we are going to find the angle between the two lines. So for that, I'm going to take a Cartesian plane. This is the Cartesian plane where, let me name the Cartesian plane. X is here. This is y, y prime, x, x prime. So for that, I'm going to take two lines. Let's say this is AB, line A to B, and this one, let's say this is angle, line C to D. Now, let's name it. This one as line 1, this one as line 2. Now, as we know, equation of a line in slope-intercept form is y is equals to mx plus c, right? So for that, what we will do, let the equation of line 1 be y equals to m1x plus c1, where m1 is the slope of line 1, and the equation of line 2 be y is equals to m2x plus c2. Fine. As I said, m1 is what? Slope. Slope of line 1. If I consider this one as theta 1 and this one as theta 2, so can I write the slope of line 1 as tan theta 1? I already said we will use the concept of slope here, where theta 1 is the angle between the line and the positive x-axis. Similarly, m2, slope of line 2, which is equals to tan theta 2. Fine. Now, don't forget our main objective. Our main objective is to find the angle between the two lines. If I consider this one as theta, what will be this? Will it be theta only? No. If you see AB is a straight line, obviously total angle is 180. If this is theta, this will gonna be 180 degree minus theta. From here, we notice that the angle between the two lines, one gonna be obtuse, one is going to be obtuse, and another going to be acute. Acute and obtuse. Fine. So first we'll work on acute, then obtuse, then we'll combine both of them and we'll make one formula which will be easy for us to do the quotients. Let's start. So what I will do, can I write theta 1 plus theta is equals to theta 2? Tell me why. Because exterior angle is equals to sum of opposite interior angle of a triangle, right? So theta 1 plus theta is equals to theta 2. But don't forget, our main objective is theta. So theta can be written as theta 2 minus theta 1. Now what we are going to do, we are going to apply tan on both sides. So what we will get? We get tan theta is equals to tan theta minus 2, theta 2 minus theta 1. Now here we will gonna apply one formula, basically a minus b, tan a minus b, it's gonna be tan a minus tan b divided by 1 plus tan a tan b. Fine. So applying that formula here, we can write tan theta is equals to tan theta 2 minus theta 1 divided by 1 minus tan theta 2 theta 1. As you know, what is tan theta 1 and tan theta 2? So it can be replaced by the slope, as they are the slope. So m2 minus m1 divided by 1 plus, my bad, m1 m2. Fine. It further can be simplified as tan theta can be written as negative m1 minus m2 divided by 1 plus m1 m2. Let's keep this as equation 1. Now we are done with the acute. Now focus on obtuse. If you see on the screen, for the obtuse, the angle between the two lines is theta 180 minus theta. So what we are going to do is we'll write tan 180 degree minus theta. It can be written as negative tan theta. Why? As 180 minus theta lies in second quadrant and tan is negative there. So yeah. And don't forget, from the equation 1, what's the tan theta? Tan theta is m1 minus m2, 1 plus m1 m2. So I'm going to substitute the value there. It will be minus m1 minus m2 divided by 1 plus m1 m2. So it's gonna be plus m1 to 1 plus m1 m2. So it can be written as tan 180 degree minus theta. Let's name this equation as 2. So combining 1 and 2, we can write, if we keep theta as the angle between two lines which represent both acute and obtuse, it can be written as tan theta, where theta is the angle between two lines. It can be acute and obtuse. So plus and minus 1 minus 2. I'll just name another so that you don't get confused. Let's say, let's keep the phi, where the phi represent angle between two lines. It can be acute, it can be obtuse. So I'm keeping both positive and negative. This is phi. So this is phi. Hold on. This is phi, positive and negative. m1 minus m2, 1 plus m1 m2, which can further be written as which can further be written as phi equals to tan inverse plus minus m1 minus m2, 1 plus m1 m2, which is the formula to find the angle between the two lines. Hence, the angle between two lines is tan inverse plus minus m1 minus m2 1 plus m1 m2. I'll just highlight the formula. Yes. Now there are condition. The condition is, remember, tan is positive in first quadrant, negative in second quadrant. If we talk about the acute angle, when we compare with the quadrant, obviously acute lies in first, whereas obtuse will lie in second quadrant. And tan is positive in first and tan is negative in second. So what I'm going to conclude here is, if the angle is acute, the angle formula is tan inverse m1 minus m2. Basically we'll take the positive. Acute means first quadrant, and first tan is positive, we'll keep it positive. Remember that acute will take the positive one. And when the angle, if the angle is obtuse, which lies in second quadrant, the angle will be negative. For negative, the formula is, we'll keep the minus sign, m1 minus m2 1 plus m1 m2, and that's the formula for obtuse. Positive and negative, remember that, positive and negative. Now we have the conditions for lines to be parallel and perpendicular. So as you know the formula, right? What was the formula? Tan, oh my god, the formula was tan theta plus minus m1 minus m2 1 plus m1 m2. This was the formula, right? Okay, let's say the lines are parallel to each other. Let's say the lines are parallel to each other. If they are parallel to each other, what are the possible angles formed by them? The possible angles are 0 or 180 degree. It can be like this or it can be like this, 180 or 0, right? As we know that tan 0 is also 0, tan 180 is also 0. So what the possible value of theta in this case is 0 or 180 degree. I think earlier we mentioned the theta, not theta, we were letting the angle as phi, so I'll let it phi. 0 and 180 degree. Done. So that means tan phi is also 0. Tan phi is 0, right? So that means, can we say that m1 minus m2 1 plus m1 m2 is equals to 0? Obviously, if this thing is 0, the numerator part is 0, right? The numerator part is 0. So the numerator part is 0. We can write m1 minus m2 equals to 0, or we can write m1 equals to m2. So this is the condition which you have to learn, that when the two lines are parallel, their slopes are what? Equal. I think this condition is already covered. So parallel means we can say that It can be written as coincident, collinear. So when the lines are parallel or collinear or coincident, the slopes are equal. Now similarly, when the lines are perpendicular, when the lines are perpendicular to each other, when the lines are perpendicular to each other, so what are the possible value of the angle? The possible value of the angle is 90 degree. You know the formula, tan phi plus minus m minus m2 1 plus m1 m2. So tan 90, if you remember, it's undefined, right? Undefined, we let it as 1 by 0. So tan 90 is 1 by 0. That means I'll write here 90 and then same thing. Okay, now so this one can be written as 1 by 0 as it is. I just ignore this one. The sign m1 minus m2 1 plus m1 m2, just equate it. If I equate it, the denominator is making it 0, right? So we can write from here 1 plus m1 m2 equals to 0, or we can write m1 m2 equals to -1, which is the condition when the lines are perpendicular. So the product of the slopes of the line equals to -1 when the lines are perpendicular to each other. Now let's conclude whatever we did. So here we have the things to remember. Number 1, by the angles between two lines, we mean acute or obtuse. Two angles, right? This one is taken as positive, m1 minus m2 divided by 1 plus m1 m2 is taken positive when theta is acute, negative when it's obtuse. The formula is used when the angles are given. If the lines are parallel, that means the possible angle is 0 degree or 180 degree. At those conditions, m1 equals to m2. And for the second condition, the lines are perpendicular, then we have m1 m2 minus 1. Let's try one question related to this. So here is the question. So you need to find the obtuse angle between these lines. So here we have 2x minus y plus 3 equals to 0 and x minus 3y plus 2 equals to 0. Let's say this is line 1, this is line 2. The slope of 2x minus y plus 3 is m1, which is equal to, if you remember the formula to find the slope is, basically for the faster calculation we use this way, minus coefficient of x divided by coefficient of y, which is 2 divided by -1, which is 2, and the slope of x minus 3y plus 2 equals to 0 is m2. I'll write directly here, -1 minus 3, which is 1 by 3. Now we have to find the angle, obtuse angle, right? See how we do it. Using formula, we have tan phi equals to plus minus m1 minus m2 1 plus m1 M2. Now what's M1? M1 is 2 minus 1 by 3 divided by 1 plus 2 times 1 by 3, which is 6 minus 1 by 3 divided by 5 by 3, and then it is basically 1. But remember, we have to take octaves, taking only negative value, taking negative value as we have to find obtuse angle. We have to find obtuse angle. So I can write tan is equals to minus 1, right? Which can be written as phi equals to tan inverse minus 1, 135 degree. So the obtuse angle between the given lines is 135 degree. If it was acute, we'll keep the positive. That's how we did it. The obtuse angle between the two lines. I hope it's clear. So now you will be able to find the angle between any two lines. I hope you like this video. Don't forget to like, share and subscribe. Thank you.